Okay people, welcome back to the next lesson. The next lesson is called Centroids, with an S there, okay. And judging by the way the semester has gone, I think this is going to be the last topic for this course. So the last topic, centroids. Now I've hunted around for notes on centroids, but the vast majority just explains how to calculate the position. Okay, so I'm going to give you a brief note, a little bit here, a little bit there. I'll explain some things, and in the next lesson we'll go on talking about how to calculate the centroidal position of a cross section. Right, the centroid, or capital C, is it over there, is a point which defines the geometric center of an object. What this means that if I have a rectangle there, and I draw a vertical line down its center, and I draw a horizontal line along its center like that there, and where those two axes intersect, that's known as the centroid. Okay, and that is the geometric center of that object there, which happens to be a rectangle. And notice, by the way, we call the horizontal one axis is normally the x axis, and the vertical one is normally the y axis. Okay, right, the centroid coincides with the center of mass or the center of gravity only if the material of the body is homogeneous. That means homogeneous means it's the same throughout. Okay, if we take a piece of steel, or we take, let's say we take a piece of steel and we cut it into thin slices, okay, and we analyze it there, the density or the material, the properties of the material is the same throughout, no matter where we take the section, okay. Just think about it. Concrete. Is concrete a homogeneous material? We can say yes, but technically it's not a homogeneous material. Why? You look at the density or specific weight. Concrete is made, it's poured as a semi-liquid into a form, it's vibrated. Inside there's steel, there's stone, there's sand there, but it's vibrated to take the form of a rectangle or a slab or a column or a beam or whatever shape it's supposed to take on the side. And then once it hardens, we remove the formwork, then we have the shape that we want. Okay, but because the concrete is man-made, we can't technically say it is homogeneous because the density is not exactly the same throughout. But when it's done correctly and properly, according to minimum standards and requirements, we can say that it is a homogeneous material. Okay, so for our purposes, as we go from here onwards, concrete is going to be considered a homogeneous material. Right, there's a triangle there. If we draw a line through the x-axis, through its center of gravity there, then that bit where the y-axis, which isn't there of it, and goes to, if it intersects with the x-axis, we call that the centroid of that object over there. Okay, there we have a 3D object. If an object has an axis of symmetry, then the centroid of the object lies on that axis. So there's a circle, of course it's a cylinder, that means that upper end and the lower end is exactly identical. And if I draw a line through its center, notice there, the horizontal axis is an x-axis, and the y-axis is also horizontal, but it passes through at right angles to the x-axis. And then through that intersection there, we have a z-axis. Why do we have a z-axis? Because the body is a 3D body, so it has an x, y, and z axis. Okay, and where all three of them intersect, that's the centroid of that body there. Okay, and it says at the bottom there, in some cases, the centroid is not located on the object. Now, if I look at the section here, I didn't draw this, but I can't agree with this. Okay, for example, if I take an L section, which like a steel section, if I draw it roughly, if I draw an L section like so, just draw one quickly there. If I draw an L section like so, and like so. And I have to find the centroidal position or the center of that there, it must probably be something like this. Okay, so there's my two sets of axes. there's my x axis, there's my y axis, and of course where they intersect, that's my position of centroid. Okay. Now this here talks about that. I'm not sure about this. It says there, in some cases the centroid is not located on the object. Okay, so the centroid here is actually sitting in space there somewhere. Okay, and if we have something like a steel channel, it looks something like this. I'll draw it roughly. Steel channel looks like that. And I'll draw its axis. There's the x axis. I'm drawing it roughly. The y axis will be sitting somewhere over like so. And of course where the two axes intersect each other, that is the centroidal position for the channel. Okay. So there are some sections which have its position of centroid sitting outside of it, but generally most centroids sit inside of the body. Okay. Let me just go over here. Okay. There's a note, I'm going to read it for you and explain some bits as I go along. It says the in structural analysis, and of course everything we've been doing so far, okay, beams, frames, all that calculations, that's all structural, that's all analysis, okay. In structural analysis, it is very, very, very important that the position of the centroid, that thing there, that thing there, that thing there, that one, and that one, and so on, of the centroid be determined very accurately, because as a member in the structure is loaded, that means whether it's in the beam, a column is being stretched or compressed or twisted in compression, it will want to tend to move or turn or bend or twist about this axis. And when I say about, that means if we have an axis there, that means it will want to do something like this or do something like so. Okay, it might want to turn that way or turn that way. And if it was triangular, want to turn this way, want to turn or bend about there. Okay, or bend or twist about or around this axis. It is called an axis because an imaginary line passes through the centroid along the length of the structural member. Now that's a cross section there. Okay, if I did this in 3D, like something like so, if I did a 3D sketch like so, okay, let me just make changes quickly here. You'll agree that's my y axis and that's my x axis. Okay, y, x, okay, and that there is my centroidal position. So that's my rectangle. I just drew it vertically. Okay, and if I draw a line through there like so, that will be the line I'm talking about there. It is called an axis, that line there, because an imaginary line, why? Because we can't see the x-axis and the y-axis. We can't see the line, it's in our mind's eye. Okay, it's called an axis because an imaginary line passes through the centroid, there's it over there, along the length of the structural member. So it goes from there to the other end at the back there. As structural engineers, if we know where the centroidal position is, we can then determine how to restrain or hold the member so that the member does not move during the working life of the structure. Okay, so people, as part of analysis, we need to determine that position very accurately. Okay, now if we have a rectangle, we know it's in the middle. If we have a triangle, we can see it somewhere over there. If we have a circle, we know it's going to be somewhere there because it says there the centroid is the point which defines the geometric center of an object. And as I spoke a few days ago in the previous lessons there, the weight of an object always acts through the centroid of the body. Okay, so that will be the center of that section there. Okay, now just another note. These here, that, and all of these here, and this one here, is a 2D body, or another word, we say it's a plane. Not an aeroplane, a plane, and not this plane. That's something else, okay? Plane, or we call it a lamina. A lamina, okay? So these are all lamina. They are 2D bodies. What does 2D mean? 2D means they have width, they have height, but they have no thickness, okay? All these cross sections here, they are actually coming out or going into the screen there, but we can't see it. We're only concerned with the plane, okay? And centroids are generally to do with laminar or plane bodies or 2D bodies, and centers of gravity is normally to do with 3D bodies. Okay, but we will only consider 2D bodies. This, we will not be looking at things like this, but we're looking at that, all of that, and all of that. Okay, so people, that's a short little introduction on centroids, what they're about, and where they are. In the next lesson, I'll take us, or maybe I can do it, in the next lesson, I'll talk a little bit more about it as we go through calculating the position of the centroid for various cross sections. Thank you, and I'll see you in the next lesson.